Hey everyone, welcome to the Tom's Hardware Podcast for November 9th, 2021. As always, I'm Tom's Hardware Editor-in-Chief Avram Pelch. I'm joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Puckett, and our very special guest, Scott from Adafruit, talking about something really exciting. We've had Scott on before, but it's a new version of CircuitPython that can act effectively as your operating system, correct?
Yeah, that's one way to think about it. Yeah, so I'm Scott Shawcroft. I go by Tan Newt online, and I've worked for Adafruit for the last 5 years on CircuitPython, which is usually a version of Python for microcontrollers, which are like really inexpensive, tiny computers. But I've spent the last, I don't know, month or two working on getting it running on the Raspberry Pi Broadcom chips as well.
How does that look, and why would you want that? Oh, shout out to Melissa, who's in our audience again.
Hi, Melissa. Yeah, so the idea is that it's going to work just like a CircuitPython device. So for the Raspberry Pi boards that allow you to act as a USB gadget, also known as USB device, what you'll be able to do is just plug in a micro B cable and have a CircuitPy drive pop up and the serial output pop up, and you'll be able to edit the code just like you would on a regular CircuitPython device. Except you have HDMI access, so all the Pis can do HDMI really well. You'll have lots and lots of RAM, so at least 500. Well, the smallest one has 256 megabytes of RAM, and then lots of flash as well. So it's going to be a whole new experience for people coming from CircuitPython, which is going to be cool. And then the other thing that we're thinking about is what CircuitPython looks like when you have native USB or native USB host, particularly on the the background noise is kind of a lot. Yeah, so the other thing that we're starting to think about is what Raspberry Pi or what CircuitPython looks like when you have a host device or a USB host support, so that you can use keyboards directly with CircuitPython. And so that's particularly for the Pi 400, where we want to have this experience of you put in your SD card with CircuitPython on it, and you boot up, and you get CircuitPython on your TV. And what does it mean to edit code that way? It's pretty wild, and we're not quite there yet, but it's going to be pretty cool, I think.
What are some example projects you guys have put together so far with what you have created?
So it's still really early for what I've got working. The one example that Phil and Lamore were showing off, that the folks who own Adafruit, they were showing off an e-ink HDMI display being powered by the Raspberry Pi. So again, the advantage of this is that this brings CircuitPython to any device that can be do HDMI. And Phil was like, "Oh, I have this e-ink one that I've got to show." So that's kind of our main focus first, is just to bring the display stuff that CircuitPython has to HDMI screens. And what you see in that demo is that CircuitPython, when it has display support, will automatically show the serial output. We did that years ago when we added display support, because one of the challenges beginners always have is finding the error messages on the serial console. So if you have a board or a device with a built-in display, showing it on the display makes it really accessible to see what's wrong with your code. And it turns out that if you do that initialization up front, it's really easy to then also just do like prints in your Python code and see what's printing. So I think once we have I2C support, which I'm putting off because I suspect it will be easy, but once we have I2C support, we'll be able to connect all sorts of I2C sensors, and you can have a very simple Python code that just prints out to your TV what the values of it are. So yeah, that's the main thing, I think. It's still very early. It's been a lot of learning for me, which has really been a lot of fun.
Scott, what was the inspiration for actually doing this? Because it seems like, I'm an old man, so I can remember the days of the 1980s with a computer interpreter. Is it that, or?
Yeah, I think it's a few things. One is, again, one strength of Adafruit, I think, is that we look at the things that are around us, the electronics that are around us, and we make them accessible to people. And I've always seen HDMI displays as like one of those things where we don't kind of like have easy access to that in the maker world. And so having access to HDMI was one thing. And then the Commander X16 and the Mega 65 are kind of like modern retro, which is definitely like an area I'm aiming for with the CircuitPython stuff. But I'd also point to fantasy consoles like the Pico 8 as inspiration for that as well. Of like, I don't want to just build CircuitPython on Raspberry Pi to be another basic computer. I want to like modernize that retro experience using a modern language, which Python is, but still have that kind of like single task, single thing that we're going for sort of experience on it. But still very much they like, you plug it in on it and it shows up on your TV and you're typing on your keyboard.
It's what intrigues me the most because, you know, I'm showing my age now, but plugging in the Commodore 64 into a television and you just got this basic interpreter straight away.
Yep.
And it's just the immediacy of typing in 10 print.
Yep.
And I saw in the video where Lamar typed in the print command on the HDMI screen, and it instantly appears like, okay, my interest has been piqued.
Yeah. And I actually I played around with I have a repository somewhere where I was playing around with the idea that you could actually edit Python code like you would BASIC. So where BASIC you put the line number and like if you type it in, it replaces it. So you have some way of like storing what you're doing. So I made an example that uses, so it edits like BASIC, but it's Python instead, which is kind of weird too.
On a side note, you can get PyBasic, can't you?
Yeah,
that runs on CircuitPython. I've had to play that myself, and it's quite good.
Yeah, and it's perfect for this sort of thing as well. I'm excited to see what folks do with this ability that we're like so close to getting there.
So is the new CircuitPython available right now for people to use?
It is not. All the code is publicly available, but you'd have to build it yourself. I do deep dives every week. I do streams where people can follow along with how the progress is going. The thing that I'm trying to finish this week and will be kind of the last thing before we get it in the main CircuitPython is SD card support. So the classic workflow with CircuitPython is you plug it in, you see a CircuitPy drive, and you edit the file on that. We still want that to be true, but in order for that to happen, we have to be able to write to the SD card. So that's kind of like the last major piece of work that I'm working on before we can make it available more broadly. So when it is ready, I'll plan on just putting it on circuitpython.org/downloads as just like all of the other boards that we support. So you'll see Pi 02W on there. You'll see the Pi 4 and the compute module 4 as the kind of first boards that we'll support. And I think, and you all are good people to ask, but I think what my plan to provide is like an image file that you can write using Raspberry Pi Imager. And then also, I think just a kernel image as well, because we had the challenge that CircuitPython can't update itself. So I think we do want a way for people to just like overwrite just the part that's CircuitPython, so they can keep all their like other Python code still on the SD card. So that's been my kind of plan. That's another thing I actually have to do first, but it shouldn't be too much work. The SD card stuff is a little bit more of an unknown.
It looks like we have a question from Russell Davis who says, does it or will it go boop beep on the Pi as a boot into an interpreter computer must boot beep on boot?
You know, I really am a huge fan of Pico 8, and they do have that bit of a splash screen with a nice little chime. I would love to see that happen. It's going to be, so audio output to the HDMI is definitely something I want to do as well. But that will not be in kind of the first version. So if you're interested in helping add that, I'd love to have it do a little chime. But it doesn't yet.
Asking the important questions.
Oh no, I mean, I am very much going for that like retro feel, but with a modern language and modern libraries and modern hardware.
We've got another one here from Simple DIY Electro Music Projects, who says, I'm very interested in getting more out of the older Pis by using them more like microcontrollers. So do you think there will eventually be a version for the older Broadcom devices?
Yeah, definitely. My plan is, so it's interesting because the Pi chips are actually very similar throughout the whole line. When we usually add a new port to CircuitPython, we have a lot of work to do around different peripherals. So the thing that does I2C, the thing that does USB, the thing that does SPI. But in the Broadcom chips that are present in the Pi, they're actually like basically the same. The thing that has changed more over time is the actual CPU cores. So there is a little bit of work to go from. So right now I'm focusing on the Pi 4 and the Pi 3 essentially. And the reason I'm doing that is because right now I'm doing all 64-bit stuff. To work my way backwards into that, I've got to add like 32-bit Cortex A7 support. And then for the original Pi 0 and the Pi 1 and I think the 2, then we have to do like ARM 11 or whatever it is. So it's more of a compiler thing and just making sure the config is right. But a lot of the work that I'm doing now should work across it all. So it's definitely my intent to support all Pi boards, Raspberry Pi boards that have a USB device capability on them. You'd be able to run it on the other ones, but you're not going to have the same experience. So I think I'll make that as a exercise for the reader for those devices.
What projects do you foresee being the most popular or the best use cases for this?
What projects do I think are the best? I think this is really interesting from the gaming perspective. We have this display I/O stuff that we did a while back, and I think this is the only platform that you'll see scale from microcontrollers like the Pico system all the way up to your TV, right? So I think anything that leverages display I/O and displays, I think will be one of those things that hopefully the universality of it is really appealing. I also think it's like one thing that we see people do is just like simple slideshows. CircuitPython's strength is that it's just a USB drive. So if you imagine putting a simple slideshow code on there and then copying all the photos over onto the drive that you want to see on the slideshow, I think that would be really simple and very powerful. I think a lot of people would just use it for that. That, of course, requires us to support more image formats than we do currently. But because the Pi has so much space, we could probably just use an existing library to pull it off. But I don't know. I'm curious to see how people use it. It's really been kind of a priority for me to both have HDMI screens, but also kind of push people's thinking about like a Raspberry Pi is not just a Linux computer. It can actually, it's just a computer, right? And anything that you can do with a computer, you can do with it as well. So I'm excited to see what people do with it.
Cool. I'm interested to know. So this is bare metal. So there's no like reusing any Raspbian or Raspberry Pi OS code. It is literally its own thing.
Correct. So the way that you install it is like if you've ever seen in your boot partition on your SD card, there's a kernel 8.image. And instead of that being whatever loads the Linux kernel or whatever part of the Linux kernel that is CircuitPython, basically. So that's the equivalent of if you're using CircuitPython and you do a UF2, it's all that machinery there. I've used the Linux kernel and the Circle project as like references for how to get things going. And there's some really good bare metal tutorials that have been a huge help as well. But I'm actually not building on those because they're GPL. And CircuitPython is MIT, so I don't want to actually use that. I have this other library, and I replied on Twitter to this. I have a Broadcom peripherals library that's really, because I'm coming from this microcontroller world, I'm trying to build all of the things that I'm used to having, but for this thing that's not actually a microcontroller. And that's in the Broadcom peripherals repository.
We have a comment from Jason Kuhn who says, I assume library support for WiFiBLE and other peripherals will not be included / supported at first.
Yeah, that's correct. Wi-Fi, I think, is going to be the trickiest of the three. The other peripherals, so like PWM and I2C and SPI, I would expect us to do pretty quickly. It shouldn't be too hard. And the nice thing is that because the peripherals are basically the same across the whole line, we can add it once and have it apply across. BLE, I think, is probably the two kind of more difficult things that we're thinking about doing are USB host, so that we can do that keyboard experience. That's probably our top priority. BLE is somewhere close to that as well, because we currently there's kind of a standard interface to extra like WiFiBLE chips called HCI. We actually have support for that in CircuitPython already. So potentially it's not that much work for us to add BLE support to this build of CircuitPython. Time will tell whether that's true or not. But that is really appealing because, as I was talking about earlier this year, we want to do programming CircuitPython over Bluetooth. So you can use your phone to send and receive files and see the serial output. We actually have that in CircuitPython 7. And there is this like fantasy of mine of being able to sit on your couch with a Pi at your TV and be programming the Pi from your phone on the TV. I think it would be really cool. So it is, it is something that I think would be cool in the long run, but I don't know whether it's that much.
David Claude wants to know, would it be a problem if the Pi version of CircuitPython contained GPL code? Is that an Adafruit requirement to go for MIT only?
It's not an Adafruit requirement. It's more my personal... I would like to keep the licensing in CircuitPython as simple as possible, and especially because the GPL is viral, I'm not comfortable integrating GPL code into all of our MIT code base. We do already have some weird licenses around vendor code that maybe it's okay, but I just rather not. And the GPL code I've referenced has been part of very large libraries, and very large libraries are hard to integrate into CircuitPython because CircuitPython is also very large. So the Broadcom peripherals thing I'm doing is trying to be very minimal, so it's easy to integrate into other things.
Russell Davis says, by the way, Scott, have you seen the Ichigo Jam stuff and the Ichigo Jam Basic for our Pi?
I haven't, but I'd love to take a look at it after I'm done talking with you. I'll take a look at it for sure. I definitely like to look at all of these other projects and get inspiration from them.
I've seen it, but only because Russell sent me some details on it a very long time ago. It looks really interesting because I love basic programming. I mean, it's the Python of the 1980s. Mm-hmm. It just works so well.
So speaking of things that are like basic, how fast does this boot?
Well, I was it's funny. This is a very common question, and it's surprising to me that that's the case. On the Pi 4, I'm seeing boot times in under 10 seconds, which I imagine is good. For CircuitPython on a microcontroller, that's actually quite slow. A lot of that time, I think, is the GPU doing stuff to get us started. I was running it on the Pi 02W yesterday. I got what I had gotten working on the Pi 4 working on there as well, and it actually booted quicker. I didn't measure it, so I don't know how long it took, but it was actually like, I noticed it was speedy, and it was like, and it might actually have to do with the less RAM on there. If there's a more RAM initialization that it has to do or something, could be part of the reason it's quicker. But I don't know. I haven't looked into it too much.
Yeah, I can't even perceive how fast it is on an RP2040 chip. I mean, it's almost instantaneous, right?
Well, we do some delays when we start up that people do notice, and we had a bug recently that just got fixed that also slowed it down. So we were about 3 seconds on the BLE boards, because we have a delay of a second to give you a chance to get into safe mode, which is a mode where we don't run user code. So the idea is that somehow you wrote user code that caused a hard crash or a brownout or something. So we have this notion of safe mode that you boot up into, and it won't run boot.py or code.py. So we will wait for a second on power on to give you a chance to hit the reset button and go into safe mode. So we actually do slow down some boot stuff in that case. I should note that if you are doing deep sleep stuff, if you're waking up from a deep sleep, we won't do those delays. So we won't waste your battery waiting for that stuff.
Makes sense. So when do you think we'll see this live? Next week?
Well, so all the code's there. If somebody does really want it, find me on Discord, and I'd be happy to send files over. That's what I did for Phil and Lamore. It depends on how this SD card stuff goes. I found a library that looked pretty promising, and I have a plan. But you never know exactly how long it's going to take to get something. So I've made a huge amount of progress. So it's just tidying up this SD card support before we can get the first version in.
Simple DIY Electro Music Project says, presumably it still has to boot all the Pi's Broadcom binary blob firmware before it gets to the kernel.
Yeah,
it's not really a question, but
yeah. So we do rely on the binary blob still. I know that there is an open source or open GPU firmware, but we're relying in CircuitPython right now on the ability to talk to the GPU and say, like, hey, give us a frame buffer. So it does a lot for us, and I'm not sure we want to give that up. So we'll start with there, and we can see later on.
Great. So is there anything else we should know we should be expecting?
Oh, anything else you should know should be expecting? I mean, I think it's going to be really interesting to see what people do with it. We're trying to make it easy, and the deep dive's a great way to keep track of it. And if the BLE workflow stuff is really exciting too, we're just about to release 2 iOS apps for that, and we have a web Bluetooth app. So code.circuitpython.org will do web Bluetooth file writing and serial output, and Maker Melissa actually did that for us as well. So the Bluetooth stuff is kind of landing at the same time that all of this Raspberry Pi stuff is getting close to. But yeah, if it sounds cool, yeah, you can join us on the Adafruit Discord server by going to the URL adafru.it/discord. That's where we do all of our CircuitPython development. So if you want to get in on the ground level, that's where to take a look.
Beer Goggler says, what's the best starting point for learning Python?
Oh, that's a good question. And I think we're just about to update. We have a guide called Welcome to CircuitPython that has resources for learning Python, I believe. That basically any regular Python resources would be good. I know that python.org or the main Python website has a tutorial as well. If that's the more structured way you'd want to go, I would take a look at just Python tutorial.
You could always just jump head in and try to make an LED flash and start with that.
Yeah, and that's the other way I would go, is like just find a project that interests you and go from there.
That would be my overall programming advice, is don't just try to learn in a vacuum, because everything I've learned in programming is because I had something I needed to do with it. If I'm just like, let me just learn something to learn, then it'll go, I won't be motivated, and it'll go in one ear and out the other. So definitely,
you've got a goal to work to. It's something you want to achieve, so you're going to work to make it happen. So that's simple. Making an LED flash, that's, to some people, it's just like, I can't even do that in a million years, but you can,
right? Yeah,
and that opens the door.
Oh yeah.
Yeah.
Jason Kuhn says, support for the Compute Module 4 would be amazing, especially with carrier boards like the Pi Unora.
Yeah, 100%. And I think that was part of the inspiration for the Pi Unora, was like mashing these two worlds together, right? Like taking a Pi and putting it in a Arduino Uno form factor is weird and cool, and hopefully cool. Time will tell.
It is cool. I've got one, and it is cool.
Yeah. I think it's neat.
built-in Neopixels on the board. So come on, it has to be cool.
Lots of blinky.
Back to the LEDs again.
Right. That'll be a challenge. I'm not exactly sure how we'll support Neopixels on that, but we definitely will.
That's interesting. Yeah, because they've got quite precise timing, haven't they, Neopixels? So could you go with something different, like an APA 102 dot star?
You certainly could, but I think the general approach we use even in CPython on Raspberry Pi OS is to use the SPI device to do it, where you just like take each individual bit and you make a SPI byte for each of those bits. And because we have a ton of RAM, that's totally fine. Like we have thousands of times more RAM on these Raspberry Pis than we do on our microcontrollers. It's absurd.
Definitely.
So I think it's going to be really interesting to see people who are like in CircuitPython and they're struggling with RAM and just be like, oh yeah, just buy a $15 02W and treat it like a CircuitPython board. And now you've got half a gig of RAM. That I want to make the Bill Gates mistake and say you'll never fill up that, but I know people will.
We'll find a way.
Mm-hmm. Especially when you get into like displays and large images and all that stuff.
So speaking of new platforms, Les, you have spent a little bit of time looking at the brand new Raspberry Pi OS Bullseye. I don't know if, Scott, you've got to see that, or Ash, you've got to see that.
I have indeed. Yes, I had a week off last week, and I came back on Monday morning to find that there's a new Raspberry Pi OS. So my day got very busy very quickly. So I'm going to go to Bullseye straight away. Let's get on. There you go. There's me. So on the whole, it doesn't look that different to the previous one, which is Buster, but there are a few bits and pieces that are different. So you see top right of the screen, you see the usual icons for sound, Wi-Fi, Bluetooth, but you'll notice something just a little bit different. And that's an update little notifier. If I just click on it now, I'm not going to do the update live because, that's not very good. But it shows all the updates that are available to install. I don't need to drop into a terminal and run them. Fantastic. So if I'm not comfortable with the Linux terminal, I could just literally just click install now, and it would install all the updates that I need. Done and dusted. So that's great.
That is a notable feature.
It's a brilliant feature. You'll notice there's a slight bit of a change here. It looks a little slicker, the whole interface. Not too different to the previous one, granted. But they're using the GTK3 toolkit now. So all the menu items, the windows look a little bit different. Just a little bit more modern. I know GTK3 has been around for a few years now. But previously it was GTK2, I do believe, with OpenBox. So it's a bit long in the tooth. It did the job, but a bit long in the tooth. But with this one, we have a different window manager as well. It's called Mutter, M-U-T-T-E-R. And this only works on Raspberry Pis with 2 gig or more RAM. So older Pis, so the 1 gig Pi or the Raspberry Pi 02W, that will default to OpenBox as standard. It's all automatic. I'm going to have a play with that, see how I can make it work. But with Mutter, this is a Pi 4 gig I'm going to get on now from an SD card. If I just move my little screen, I shall go to this one and move that out of the way. There you go. You can see the interface is just a little bit faster to run. And to just quantify how fast it runs, I'm going to go to YouTube. So let's get rid of this here now. Don't need that. There we go. I'll get the right one eventually. There we go. Right. So this is YouTube on the Raspberry Pi 4, connected via Ethernet to our home network. I'm going to go to YouTube. And this is where Pis normally have a problem. Normally a Pi, when it loads YouTube or streaming media, it grinds to a halt. It drops frames left, right, and center. But I'm going to load up a video that I know we can play.
Our current live stream? It's live right now. We're live now.
I can try it.
That would be ultra meta.
We can watch ourselves. Right, so this is going to be the live stream of us streaming on this Pi.
This is the real test.
Okay, so there we are.
That's
So you
great.
can see it's going to get the resolution set to 720p. That's auto, lovely. And let's get stats for nerds on. So we've dropped 9 frames out of 440 so far. Normally on a Pi, it'd just be a complete slideshow. But this is not. So I'm going to go full screen. This is, again, where the Pi will normally drop frames. We're going to drop some, but still 9 out of 637. 14. There you go. Was it 0.1% we're at? Something like that? Fantastic. So we've got streaming YouTube playback live on the Pi at 720p, 30 frames, and we're not dropping many frames at all.
That's not bad.
That's really good. There's no audio, by the way, because my capture card's just not playing ball tonight.
That would be too weird if you tried to. The amount of feedback you would get on that probably would not be great anyway.
The video's already gotten crazy.
That would hurt quite a lot.
It'd be like
this
an
is
infinite cat project.
So this is also to do with another update that's behind the scenes. This isn't to do specifically with Bullseye. It's a new version of Chromium that uses the hardware acceleration. So we can stream. I've not tried any of the streaming services, but you can stream YouTube at 720p brilliantly. I want to test Netflix and Disney Plus, that sort of thing, to see what we get. Now, I'm guessing there's going to be standard definition playback on that because we haven't got security. Is it Widevine, I think it's called, to play it back? But it looks interesting. I'll have to give it a go. So I've got a little experiment going on here as well. I'll go back to my capture screen so you can see my little setup. So you will see I've got 2 terminal windows open. And I'll use the right mouse this time. There we go. I've got a camera command. Now, normally with the camera, you'd use Raspberry Still, Raspberry Vid to load a video. They're no longer in Raspberry Pi OS. Bullseye has got rid of them. And we're now using libcamera. So it's a libcamera API. This also means we haven't got Pi camera. Now, if you do any work in Python with the camera, you normally use Pi camera done by Dave Jones, who's been a guest on the show, in fact. That doesn't work at this time. There is work going on behind the scenes to try and make something happen, but at the minute, you're just restricted to libcamera. Now, it's not a restriction, that's a bad restriction. It just means you've got to change how you work. It also means if you really need to use Python for the camera, stick with the old version Buster for now. But I'm going to show you the camera working. So I've got a camera set up, which is even more meta. Now there'll be a camera on me in here for another capture device. This is fun. I'm going to capture a JPEG of me, and I'm going to give it a timeout of 10 seconds. So you'll see, there's me. Hello. Waving hands. How you doing? You all right? There we go. And just a bit of time to kill. There you go. It's captured. Ready to go. And I can open that picture. When I can get it, there it is. There is me hiding behind a picture of me. There you go. So the camera works. We can do video. We can do, I think it's 1080p video. We can do, it's all the same as before, to be fair, and some high-res images. So another area where it's a little bit different for Bullseye to Buster are hats. So I've been playing around with hats. Specifically, the Explorer hat you can see here on this camera. I've also been playing with the Sense hat as well, Raspberry Pi Foundation's own board. At this moment in time, if it's first party, so Sense hats, that sort of thing, it's going to work. Third party, so Pimoroni, Fortronics, SparkFun boards, at this time, they're not going to work fully yet. Now, I know that this board works. I've been talking with Phil Howard from Pimoroni today about this board in general, so I know it works. So I'm going to show you a quick test to make sure it all works, and this is where the demo usually goes horribly wrong and breaks. So you can see the Explorer hat's come to life. The lights are on, the wheel's turning, and I've just knocked it slightly out of the way. There we go. And you can see when I touch the inputs, all working, it responds. Now this is where it usually crashes. Oh, it didn't this time. There you go. But there are a few things that are different behind the scenes that need to be tweaked by Phil and the team. Now, Phil's going through the entire catalogue of Pimoroni boards to get these fixed, and I'm guessing that other third-party suppliers will be doing the same to their boards. So at the minute, if you rely on a board for a project, stick with Buster. If you just want to play around and install latest software on your Pi, try Bullseye.
So, Scott, have you tried Bullseye, and is this going to affect the Blinka libraries?
I have not tried it. That's a better question for Melissa. Actually, I think she's been testing it today and yesterday, and Carter, who also works for Adafruit, has been testing it as well. Jerry from our community has been testing it. I have not. I'm more bare metal interest than running the latest Raspbian, but I know that other folks have tested it and made sure that everything looks okay.
Great. Well, I just want to thank everybody for tuning in, especially Scott for joining us and keeping us up to date on all the latest and greatest developments with CircuitPython, which is such a big part of everyone's life, and we're so excited to try this on the Pi. And thanks to everyone for watching. We are here every Tuesday at 2:30 p.m. Eastern, 7:30 p.m. UK time, and of course, anytime you want to find us on YouTube. So we'll see you all next week, and thank you so much.
Thanks for having me.
Thanks so much. Bye.